Alright, so to wrap up this example, number 11, I'm going to use the calculator to randomly select 5 juniors from the 2012 Oak Ridge High School football roster. Okay, so I did numbers 2 to 88, select 5 at a time. And again, we're going to have to skip over a lot of numbers because they're not all juniors and not even all the numbers are represented on the football team. Okay, so you're going to get different answers than what I get, which is totally fine. The first 5 numbers that I had were 78, 6, and actually, you know, we're going to change this problem to just 3. It's going to take us a long time just to even get 3 this way. Okay, so 6, I had another 78, 59, and 82. Okay, so you don't have to write all these numbers down. Just look at them on your calculator. I'm just trying to show you what I'm doing. So when I left 78 works. Okay, that is a junior, so here's the first one I've got. Number 6 is a junior, so that works. Awesome, we've already got 2 down. And 78 is a repeat, so I don't want to use that. 59, we don't have, and then 82 I don't have. So I need one more player, and so I'm just going to hit enter again to get up my next 5 random digits. Okay. And so just hit enter again to try to get another digit. I ended up with the next one I got was 54, and that is a senior, so I'm going to keep going, and I end up with number 17 is the next one that's going to work, and so that's a new number for me. And so 54 didn't work. So those are my 3 numbers. Using the calculator, most likely you have different numbers, and that is okay. So I'm just going to rate the people that I chose in my sample, because again, the whole point is who is selected, not just the numbers that you got. So Austin, Hamilton, 6 is Colton. And my last one is 17, Tyler Alley. So again, the purpose is selecting the people. Do the same thing, and we're again just going to change it to 3 seniors. So we get the process, but we're not going to be here all day recording this. Okay. So here we're going to change this to 3. Let's try to select 3. So again, same command, random integer 2 to 88, and when you can put it at 3 at a time. We're going to be canceling out numbers, so just taking 5 at a time is fine. It doesn't matter if you want to change that to 3, that's perfectly acceptable. Okay, so again, your numbers are going to be different. The numbers I got are 78 again, 6, 78. These are, sorry, looking at the wrong list. Okay, so sorry, I got 84, 7, 58, 66, and 57. And of these numbers, to try to get seniors, there's no one who's 84. Number 7 works, so that's my first senior. Number 7 works. 58, nobody. 66, nobody. 57, nobody. Okay, so I'm just going to hit enter again in my calculator and get another 5 random digits until I get somebody who is a member on the football team and also is a senior. Okay, so go ahead and keep trying to select them. So eventually, I got 59. Still doesn't work. Sorry. So that should be 54. So eventually I got 54, which is another junior. Sorry, another senior. 54, Jake Nell is a senior, so that works. And then the last one that I got, after I keep hitting enter just to try to find another senior, is number 12. And that is Kevin Valdez. And so that's eventually who my three seniors were. And again, you should have different numbers, but the process is the same. And so continue to go until you get your three seniors. Now for part D, we don't actually have to do it. Explain how you would get a stratified random sample of 16 juniors and seniors. So a total together of 16. A lot of times you'll see this broken up so that you have the same number of both people. So like in this case, we're doing juniors and seniors. Sometimes it's guys and girls. It does not have to be the same number. Okay, so I'm going to say that you just take a random sample of juniors and then a random sample of seniors. We could take 8 and 8. We could take 10 and 6. It does not necessarily have to be the same amount in each group. Normally that's kind of what we'll do, but that is not a requirement. Okay. So we're just going to break them up, take a random sample of 8 juniors. Let's split up the juniors and seniors and then take a random sample of 8 seniors to get our total sample of 16, in this case, football players who are only juniors and seniors. Okay, so again, it doesn't have to be 8 and 8. You can break it up into any other increment that you want, but that's just how one way to do it. All right, last question that we're going to talk about in this video is example 12. Which of the following statements are true? So here we're going to practice some of these multiple choice questions because they tend to be difficult, especially the choose which one is true and there's multiple options. So number 1, random sampling is a good way to reduce response bias. Number 2, to guard against bias from undercoverage, use a convenient sample. Number 3, increasing the sample size tends to reduce survey bias. And to guard against non-response bias, use a mail-in survey. Okay, so let's see if we can pick out any that just jump out as things that we can cross off to try to narrow it down. Okay, so let's look at number 2, for example. To guard against bias from undercoverage, use a convenient sample. Okay, so what is a convenient sample? Convenient sample is normally just taking something that's convenient. So the example that we talked about was standing in a shopping mall and asking people about the economy. It's easy to get a large number of people, but it's just a convenient sample. The problem is what happens like in that example in the mall when you're just selecting people who are at the mall and you're trying to find out about the economy. Do you have everybody represented in your sample? No, we talked about that most people who are really going to be affected by the economy are going to be left out. So when you do a convenient sample, most of the time this tends to suffer from undercoverage. Okay, so for this, it tends to suffer from undercoverage. So this one is not true. Cross off. Number 2 is out. All right, any other ones jump out at you? Let's see. What about increasing the sample size tends to reduce survey bias? Usually it is a good thing to increase your sample size, but survey bias means that there's something wrong with your question. Somehow the question itself is flawed, the survey is flawed, either how you're conducting the survey, there's something wrong with that. So just by taking a larger sample, it's not going to fix the bias of what's wrong with your survey. So in this case, if the survey is biased, taking a larger sample is not going to fix that. All right, so we can cross off number 3 though. What about number 4? To guard against non-response bias, use a mail-in survey. Non-response bias means that people are not responding, and that's usually one of the main problems with a mail-in survey, okay, is that people do not respond. So this one is a no-go, okay, because mail-in surveys suffer from non-response bias. Mail-in survey. Sorry, my writing is terrible. Okay. Last one, so this one either is true or none of them are true. Okay, we've crossed out all our multiple choice options over there on the right. So random sampling is a good way to reduce response bias. Okay, what is response bias? Because random sampling is good. That's one of the things that we want to do is random sampling. It's a good way to reduce response bias. So what does response bias mean? Response bias is when whoever's asking the question, is influencing how people are responding. And so either by their behavior or how they're re-explaining the question, or somehow they're influencing how people are responding. So the random sampling technique is good, but if you're asking questions in a flawed manner, just because you took a random sample, that's not going to fix the response bias. Okay. So here we can just say a random sample can't help response bias. So this one is out. And so the correct answer down here is E. None of these are true. All right, thanks for listening.